You guys ever have one of those days where you wake up just feeling thick-headed and stupid? You know the ones I'm talking about. The ones where when you first get up out of bed and you stumble down the hallway to the kitchen in hopes that you find that holy grail of a coffee pot and that it will bestow upon you the gift of caffeine to try to shock your system back into connection with reality and break you out of the cross-eyed and drooling on yourself funk that you find yourself in. Well, today was one of them days, and no matter what I did, I couldn't throw enough coffee at the problem to get all the mashed potatoes out of my brain and try to get it hitting on all eight cylinders to make sense of anything.
Hey y'all, everybody's favorite bumpkin here. Sorry I missed you guys on Thursday night. That was kind of a me problem. It kind of comes with getting old and, shit happens. Basically, just to give you the rundown, I pinched a nerve in my neck right here that runs down into my shoulder, and the last couple of days I've been pretty friggin' miserable. It's kind of like a bobblehead that goes to the retirement home. But anyway, we're on the uptick from that now. We spitballed some ideas back and forth, and I came up with some stuff that we're going to be doing on Liberty Risk over on the Ramblin' Park segment for this coming Thursday night. But tonight, what I want to show you guys is some stuff that I've been needing to make, number one, because I wanted to make it. Number two, it's some stuff that I need for doing some of the parts on Liberty Risk. We got to get back on that thing and get this thing up and running. I want to apologize on the front side here. I typically don't like videos like this. We're going to be doing some of that disembodied hands, working around stuff, okay? So just sit tight, pull up a chair, grab a beer or whatever. You guys saw the video that I put out a couple of weeks ago where I was showing you stuff on my lathe with the four-jaw chuck and all that. Now, if you guys will remember in that video, that four-jaw chuck that came with my lathe, that's something that was shop built, if you will. It's a faceplate that's meant for holding irregular shaped parts to where you can clamp them at an offset angle or something like that, but it's not really meant for something that's entirely round. Now, I've got some parts like that that I'm going to be making later on down the road, and I need my faceplate back. I still need a four-jaw chuck to where I can offset parts and hold stuff that's, again, not round. I've got a smaller four-jaw chuck that I bought a few years ago that I used on my mini lathe. And I had an adapter plate that I made for it, and it was actually kind of comically big. I mean, that thing looked like it was this big around whenever it was strapped to my Mini. It's a little bit bigger than what I had. It's still not too much for the lathe to pull. Actually, that faceplate with that big, ginormous four-jaw chuck that was on there, that thing weighs a lot, man. And the drive belt on my lathe, it's small, like skinny, small. The drive belt on that thing's actually only 5 millimeters wide. I mean, that's really damn small. And I've always kind of wondered about that. And there's been a couple of times where whenever I've had the lathe running and I've thrown it into gear to start things spinning, it's caused that belt to pop off. It's only going to be a matter of time before something gives out and breaks there because I've got way too much weight on the spindle as it is. So here's what we're doing about it. Now, if you guys remember in the last video where we were talking about lathe stuff and stuff that spins around and around and makes lots of chips and curlicues, the four-jaw chuck that I had on my lathe, like I said, that was something that was shop built, and somebody had drilled and tapped that thing into the front of the faceplate. But also, I've got a more conventional three-jaw chuck on there. The problem I had with that is the run out on my three-jaw chuck was, honestly, it was awful because that chuck was wore out. The jaws in it were actually sprung. I'm big on visual aid stuff. The run out on this chuck was pretty bad. I'm not going to throw it away because I've got other uses for it and things I can do for it. But the problem that I had with this thing, these jaws are sprung to where the outside part of them is further away than the inside part. So if you grip something kind of light-like with it, it would grab way deep down inside instead of evenly all across the length of them, and stuff would wobble around. So to overcome that, I had to just hoss on the thing to get everything to clamp down and to find its center, if you will. Now, the problem with that is if you're doing soft materials like plastics or aluminum, something like that, guess what? You just put a big old gouge in it. If you're having to do a cut on something where you've already got one part where you've got a machine surface established and you've got it down to the tolerance that you're looking for, guess what? You just destroyed that by gripping the crap out of it with the chuck. This guy, he's going to get retired, at least from lathe duty. My four-jaw chuck that I bought for my mini lathe, it's a 5-inch chuck. Well, This is a 4-inch chuck. So how do you marry those two together? Well, these are normal flatback chuck, and they're more or less an industry standard, if you will. They don't have any kind of adapter or anything on the back, where it attaches to the lathe to accommodate different makes and models, different attachment methods. And my lathe in particular has got a screw-on type of chuck where it screws onto the spindle nose. It's threaded. Now, it's kind of a weird bastard thread. It's 39 millimeter with a 4 millimeter pitch. You can get pre-made adapter plates for these things, but two problems with that. Number one, you got to spend real money. In this case, they're about 75, 85 bucks a piece, depending on where you shop. And number two, they make them for a 3-inch, a 4-inch, and a 6-inch. Well, I'm kind of in between on that because my chucks that I'm using, they're 5-inch. So here's what we did about it. Now, this is the original backing plate that went on my old 3-jaw chuck. It was just kind of hanging out, and I figured, hey, let's give it a little bit more elegant job in life. Unbolted it, and then I blueprinted out the step, that little register lip on the back side that engages with the back of the chuck itself where the two pieces bolt together, and we made us a little adapter plate. The internal dimensions of this chuck, as far as the diameter of it, the depth of that register lip, and the diameter of the register bore here, where it keeps everything centered and keeps everything concentric, we had to make this piece of aluminum accurate to those dimensions down to 1/1000th of an inch, give or take. Starting out, this was a piece of, it was probably about 8 inches square. Threw it in the bandsaw and did a quickie, dirty rough cut on it real quick just to take off all the excess that I wasn't going to use. That way I didn't turn it into a giant pile of chips and glitter here in the shop floor. I pulled this back plate off of the chuck that was on the lathe, but I left this bolted onto the spindle of the lathe after I made sure I dressed all these mating surfaces. That way we can make sure everything is concentric. That way everything is flat and square. I took this and I laid it on this really ugly piece of aluminum at this point. But I laid this thing out and I measured out the center point of it. And then we laid out the pattern for these 3 mounting bolts here. And that's where things get interesting. You can use a center punch, you can use a drill bit, whatever. But there's not a whole lot of accuracy there. Even if you got a good eyeball and you're paying really good attention to what you're doing, you're still going to have some irregularities there. It's not that big of a problem because we're taking a rough cut part and we're making it round, but we've got to have consistency amongst all 3 holes to where it bolts up evenly and it doesn't bind up or induce a lot of run out, a lot of wobble to the part we're trying to make. That's where these guys come in handy. I don't know if you can see that or not. I'll try to get it in focus here for you. That is a transfer punch. The way they make these is they're indexed just like a set of drill bits. Looks like a little spiky, Lego block. This is like the boss level Lego block to inflict the maximum amount of pain possible when you step on it barefoot. These are indexed and they're sold by drill shank sizes. So what you do and how you use them is after you've got a hole that you've drilled on a part or something like that, and you're trying to get that hole marked in the exact spot of where you need it in your new material, you take this, it's the same size as your drill hole, it's a tight fit, it's a snug fit, but it fits, and it just barely passes through there. You've got the pokey part of your punch there to where once you slide it down your drill hole and you've got your material held down, pip, hit it with a hammer, you just exactly copied the exact center of that hole that you're trying to line up with. Granted, it may have a couple of thousandths of an inch of variance to it, but it's better than, a couple tenths of an inch because remember, guys, drill bits like to walk and wander whenever you're trying to poke a hole in something. So I had this flat piece of aluminum, and I've got to be able to bolt it to this backing plate to where I can copy off these holes, and then I've got to copy off this profile with this register bore to where it holds everything centered. We didn't have the register bore established, nothing like that. So what I did, I took this, lined it up, centered it up, I used the transfer punches to mark out my 3 holes, and then I drilled and tapped the 3 holes that this is going to mount to the backing plate with. Now at that point, it was sitting on top of this face for the register bore on the backing plate. I hadn't cut that pocket yet. At that point, it doesn't matter. We take these 3 holes, thread them, put the bolts in them, get it torqued down, and then We do this in reverse. We cut the pocket for the register lip on this backing plate in it first, and then after we get that pocket established and out to the proper dimension, we flip it around, and that's when we bolt it up solid, and we can do all the rest of the finish work from that point. After we got everything square here, we made sure that we were sitting down flush and even, got the bolts torqued in it. That's when we chunked the whole mess into the lathe again, and that's when the snowstorm began. It made a mess, I ain't gonna lie. Strategically placed piece of cardboard and a magnet was about the only thing that kept me from getting a face full of chips from it. So fast forward, here's what we got. So now we got this put together, and like I said, it may be a little bit on the thick side, but that leaves me some wiggle room if I've got to make modifications to it later on down the road, or if I got to go back and correct a mistake. Full disclosure here, I already checked my shit over. It's flat. It runs straight and true. Because math and stuff. I know it makes my head hurt too. Now, if you guys notice, this is a 3-bolt pattern. Small thing there. There's 4 bolts there. Why? I'll show you why. All right, for the most part, usually whenever I'm doing lathe work and making parts, I'm using a 3-jaw chuck because number one, it's quick, it's convenient. My chucks that I've got, they self-center. Now, the 4-jaw stuff is whenever you need a little bit more precision, or if you got something that's a little wonky, a little weird, and you need to make a whole offset, kind of like what we did with the handlebar bushings on Liberty Risk, or if you've got, say, a part that's square or other than round shape, let's put it that way. We've got to get a backing plate that's drilled for a 3-bolt pattern, and we've got to get it to marry up to a 4-bolt pattern for a 4-jaw chuck. And then there's the small matter of how are we going to get the bolts in there? Because there ain't a whole lot of real estate back here. We'll get to that. This register bore here, even though these chucks are somewhat standardized in their mounting blueprints, that's not always the case. My 4-jaw chuck, this register bore, it's 2/1000 of an inch larger than what my 3-jaw chuck was. 2/1000 of an inch on a chuck that we've got to adjust out to center anyway, no big deal. I'll take it all day long. But we still come back to that problem where we got 4 bolts in a chuck and 3 bolts in a backing plate. Here's how we get around that. Okay, gang, disembodied hand video time. Bear with me. Here's our 4-jaw chuck. Obviously, it's got 4-bolt pattern on there. We got to figure out how to make this thing work on a 3-jaw backing plate with a 3-bolt pattern. So, you see the problem. 3 bolts, 4 bolts. It fits really well, but we only got 1 bolt hole out of 3 that lines up. That's a problem. Or is it? Okay, slight pause for bumbling home hobbyist faux pas there. Just to line these up, we're going to take our transfer punch that just barely fits in our threaded hole, and we're going to basically use him like a C&I dog. Take that. Oh, wait a minute. Bad news. That don't fit. What to do? Well, that's too big for that hole, but it fits this hole really well. How are we going to do this? Keep in mind, there's always options, guys. That one. That little guy right there. That's a good fit. So this is going to be our master hole. And what we're doing, we're taking the tap that we already threaded these holes into this backplate adapter with. That's the one that we're guiding off of. Because we found this one hole here that is just a little bit looser than the other 3. But it's still a very snug fit on the body of our tap. So we're going to use him as the guide hole. And we're using that tap as a guide. Now, before you do this, you want to make sure, and I mean make really sure, that you're not going to get that thing down in that hole and get it bound up. Because if you do, you're going to have a bad day. And that is fitting just a skosh bit snugger than what I feel comfortable with. So we're going to take that hole and make it ever so slightly bigger. This is not a drill bit. This is a reamer. These are not meant for making holes, period. These are for making holes that you've already got close to what size you want, the exact size you want. Now, this is an M8 reamer. It's cut for 8mm, obviously. Now, if we measure this guy out, the flukes of that reamer come out at 0.315. Got to be gentle with that thing. While it's unbolted and exposed, we don't want to beat it up because we spent a lot of time getting that thing square and flat and getting it parallel. Now, the good thing about dealing with stuff like this is, gray iron, it's cast iron, it's fairly soft. It's easily workable. The only downside is it's messy. It leaves stuff that looks like gray, greasy cookie crumbs everywhere whenever you drill it. And whenever you drill it or you do any kind of machine work to it, you want to make sure that you do it dry. You don't want to put any kind of cutting oil on it or anything like that because that just makes the mess that much worse. By the way, slight sidebar here. I'm trying out these new brushless cordless tools from Hypertough, and yeah, I found a cheaper option than Harbor Freight, if you can believe that. This stuff's from Walmart. Yes, I said that right, Walmart. And it's cheaper than Harbor Freight. These are brushless. They're a lithium battery tool. They've got like the drill here. I've got an impact driver. I've got a 3/8 impact gun, and I've got a Dremel tool from them that I bought the other day. And so far, I am loving this stuff. The runtime's excellent. They're god-awful powerful for their size. They're tiny. They're light. They're easy to get into all the little nooks and crannies. Go check them out, okay? Don't snooze on these because right now, these are a hell of a buy. We're going to take that and set him off to the side of the bench just a little bit to where we got room to let that reamer pass all the way through. Now, full truth here. Normally, you wouldn't put a reamer in a hand drill like this. This is a precision drill bit, if you will. So you'd want to have it in a drill press or over in the mill. Now, that's where I made these holes at, but I got one that's being just a little bit stubborn, so I got to knock down some of the high spots. Our shank's nice and clear now. Seriously, go give these a look. Do a little bit of Googling, watch some YouTube on these things. Torque Test Channel's got a real good review of these things out there. They stack up really well, guys. Check them out. It's worth a look. There we go. Nice, snug. It's a very tight sliding fit, but it has no perceptible play in it whatsoever. Okay, there. So we got our tap in our backplate adapter here. We got our hole reamed on the chuck to where we can get it to slide over and act as a guidepost. Oop. Wrong hole. Insert off-color joke here. Nice snug fit. Everything's centered. Everything's aligned. We're using that one hole. We're actually only going to be drilling and threading 3 holes in this because we've already got one that's pulling double duty. So we got our centering punch here, or transfer punch rather, and drop that in the hole. You got a little tiny bit of wiggle in here, but the thing is I'm kind of in between sizes, and the next size up's not going to go in there. Now these are graded in 64ths of an inch, just like your average drill index set is. I have had in the past where I've had to make these out of a piece of round stock for a specific hole because it was an oddball dimension and I needed it bang on exact. So if you're at a point where you've got the ability to do that, don't be afraid of doing it. Think of it as a disposable tool based on desperation. So we just drop our transfer punch in there because we got a tap in this hole. We're using this threaded hole here that's already existing. So we just got to mark out the other 3. Now, when you're using transfer punches, do not go all kind of Hulk smash. If you guys notice, my little pecker's making an appearance here. Drop him in there, hold it down to where it's not going to bounce. That's it. That's all you need. Because you're not looking to make a huge bomb crater of a punch mark. You're just wanting something that you can identify. There's that one. And lastly, that one. All right, so now we got our holes mapped out. We can take this guy and, set him aside. Remember, we used our tap here, indexing off this one hole because it lined up. We just had to mark out the other 3. We got our tap here, which is our guide hole. And then over here, we got a punch mark here. Got one down here at 6 o'clock. And then lastly, got this guy over here. The thing is, they're all centered up off of that chuck body, and that's all where they're going to land. as long as I do my part. All right, guys, I'm trying to get you in here to where you can see. Just ignore the piece of blue plastic over here to the side. I'm just using that to kill some glare that's coming in through my shop window here. So we've got our adapter plate here, and we've got it bolted down in our vise on the mill. You can do this on a drill press. This type of drilling work, you can do it on a cheap Harbor Freight drill press. I've done it before. The main thing is you got to have what you're drilling clamped down solid where it's not going to move. If you don't have a vise, you got a hole here. Take a bolt, run it through there, stack up some washers, bolt it up from the bottom side of your drill press table, whatever. Unless you are really, really good or extremely lucky, which I am neither, you're not going to be able to get these holes exactly centered by drilling this by hand, okay? Don't even try it. It's just going to end in frustration for you. You notice my center drill bit here. I like these long ones, and I like using them for doing precision holes like this whenever I can, because I kind of use that as a rough indicator. I'm not real high speed and fancy where I've got a programmable DRO or anything like that, but I can use this and I can use my eyeball to tell when I'm in my center punch spot, and I'll show you how. So I've got my table on my mill unlocked, and keep in mind this is a little tabletop unit, guys. Y'all know that. So I got a little bit of limited room on this thing. So there, that looks like it's going to land pretty close. Let me get you guys in a little closer to where you can see what's going on here. Okay, so I've got my long center drill here, and I've got my punch mark. Going by the eyeball, I'm pretty close, but let's bring it down real slow like and see exactly where we land. Yeah, we're a little off. I don't have that drill bit touching on that backing plate, but I'm really close. That looks very close. Now, pay attention to the very end of the drill bit here. I've got the flutes turned this way for right now. That's lining up pretty good with my punch mark. I don't have any deflection or anything like that. Now I'm going to move this just so you guys can see what I'm talking about. Now if you notice, I didn't move it much any at all, but pay attention right here. When I bring it down to where it just touches, see how it scooches off to the side just a little bit? That's because that drill bit is flexing for the tip to land in that punch mark that we made. Okay, so we look good there side to side on our x-axis. Let's turn those flutes 90 degrees to where the flutes are running this way, and let's look at it from the side. Yep, I got a little bit of deflection. My part's a little too deep. So let's bring that back just a smidge. Okay, that's centered. Now what I'm going to do right now, because I can and I've got the ability to, I'm going to hit the table locks on my mill to where my table is held stationary and it doesn't scoot around, because you're always going to have a little bit of backlash in the lead screws and what have you. If you're doing this with a drill press, if you have a drill press vise, same thing applies. Lock it down, do what you got to do. If you have to, ditch the vise, get a long bolt, stack up some washers, run a bolt down through this and through the table on your drill press, snug it down. Don't tighten the crap out of it, but just snug it down. And you can do the same thing with the hunt and peck type of method of centering like this, watching for your drill bit deflection. And then once you get it centered, go ahead and tighten this up to where it's not going to move. Since we're drilling aluminum, WD-40 is your friend. It makes for a hell of a good cutting oil. And remember, kids, there's always time for lubricant. And yes, my mill's still got the stutters right now. I'm still working on that, so just please be patient and bear with me. It'll poke a hole. It just takes us a little time getting there. What, that? My light? No, it's not in the way of the shot. You can see a little bit of it, but it's not in the way. All right, now the thing with the center drill, it's not meant to drill the hole all the way through. It's just meant to make your starter hole and get it straight and square. I don't have enough room on the y-axis to go back and forth, so I am going to have to move this part to do this last hole here. But I can transverse it side to side to where I can do this hole and then this hole. That way I keep my depth on the y-axis on the same plane. Still need to check it though, because keep in mind, guys, we're clamping down on a part that's round. It doesn't have any reference surface to it. And yep, just like that, this hole's a little bit further back, so I got to move the table towards me to get it centered up on that. Move it just a smidge there, we're good there. Okay, cool, gang's all here. Give it the hock to, and then rinse, lather, repeat. Okay, so I got 2 of my 3 holes spotted and marked. We're going to go ahead and drill these for our tapping size bit, before we move our part to do this last one, because we're already set up for these two. There's no sense in screwing all that up just to put one more spot drill here and then have to go back and redo the whole setup again. Now, ideally, we would use a 6.8 millimeter drill bit for drilling a hole that you're going to tap for M8, but I don't have a set of metric drills, especially a set of metric drills that are staggered down by a tenth of a millimeter, so we're cheating a little bit. That's a regular old 11/32 bit, and guess what? It's exactly 2/1000 of an inch bigger than what the hole is supposed to be. By the time we run a tap in there and cut the threads and the threads are established, it ain't going to matter. Use what you got. But check it, check your math, make sure you're not going to shoot yourself in the foot. It's easier to make a hole bigger than it is to put something back in there to make it smaller. No, it ain't going to be too long before I build a power feed for this thing. Y'all stay tuned. Now remember, our part is slightly rotated on the table off of true center line with the table. But I've already got my drill bit in here. I've got a starter hole here. Remember the little wiggle and watch it bend trick I was showing you with the center drill to find your punch mark? You can do the same thing with a full-size drill. You just got to pay attention, okay? That looks good. Give it one more check on side to side. Yep, because we did move a little bit. Because keep in mind, we're not square here. Lock it down, spit on that thing, rinse, lather, and repeat. Now, the reason you want to peck drill it like that is because when you take small bites out of the hole working your way down, that'll keep your drill bit centered, because drill bits, no matter what kind of a tip profile they've got to them, they've always got the possibility to wander off to one side or the other whenever you keep constant pressure on them, because they like to follow the path of least resistance. Also, whenever you're drilling aluminum like this, aluminum is gummy, it's stringy, it likes to grab a hold of a drill bit, it likes to ball up around the cutting tip on the edge of the flute profile. So work it back and forth like that to where you can break the chips and get them out of your way. That way you can make sure your hole is, number one, where you want it to be, and number two, make sure it's actually straight. Now, as far as this part goes, where we've got to get back around here and do this front hole right here, if you've got a vise on your drill press, or if you're fortunate enough to have a mill, keep in mind, we're grabbing something that's round on the backside here. You're already indexed as far as your depth and your cross slide position, at least for the most part. Loosen the vise up just a little bit. Just turn your part. Give it a little bonk bonk to center. Don't want to go too crazy with it, because we've already got a machined and established surface on the face of this, and we do not want to screw that up, because I put a lot of time into getting that thing flat and true. Last hole. Go back to our little center drill here like we did starting out with the first two. Do it all over again. Slight sidebar here to give you guys a little bit of info that you may not be aware of. That regular tap. You know, I mean, this is a regular taper tap. If you look close there at the tip, it's got a little bit of a lead-in angle to help it start in the hole and start cutting. And this is what you're going to commonly find online, Harbor Freight, Ace Hardware near you, big box store, whatever. If you're doing a lot of threaded holes or you're doing a lot of fab work, it might pay for you guys to buy a couple of these individually for a lot of times where you're having to punch the same hole over and over. Look at this guy. That is a machine tap. And you notice how that thing's fluted up? It looks like a drill bit. Big difference on these. With a regular straight flute tap like this, you got to run it in, you know, quarter turn, half turn, whatever. Then you got to back it out to break the chip, because what happens, the chips pack up in these flutes on the tap and it'll bind up and you run the risk of breaking the tap off in whatever you're trying to thread. These guys, they're a little harder to find and they're a little more expensive. Not terribly so, but you get what you pay for. The biggest advantage on the machine taps, though, is because of that spiral fluting that they have, you can cram these things in straight, just keep on twisting them, and all the cuttings will self-eject. They will literally come up out of the hole that you're tapping. It looks just like a tailing from a drill bit whenever you're drilling a hole in the first place. You don't have to back them up and constantly break the chip. And number one, it works better for holes where you're trying to establish a tight tolerance threading, you know, where you're not working the tap back and forth and open up that tolerance. You get better thread engagement. But also, if you've got multiple holes that you're having to do over and over, it just saves you a lot of time. Oddly enough, I just mentioned to you guys something about, how straight flute taps will build up chips and they pack up in the flutes. Look right there. I was in that hole maybe a half of an inch deep. Those are filled. That's why we use cutting oil, because if you didn't have that, instead of it cutting, it would smear, and also all those flutes get packed up, or all the chips rather get packed up in the flute to where they'd be stuck there, and they're going to tear the shit out of your hole that you're trying to, get somewhat round and threaded consistently. Okay, adult time here, kids. Let's set the junior high locker room mentality aside here, because I'm using a lot of terminology here in a repetitive nature that some people with a less than pure standpoint could interpret as something perverse or innuendo-ish. This is a family show. Mom's watching, y'all. Sinner. The magic eraser that's bestowed upon mechanics everywhere by Metallicor, the god of machining. Brake clean. Yeah. All right, just to keep you guys happy, because I know more than likely there's a pissing match going on down in the comments right now. We're going to take a little bit of the high-speed magic motion lotion, and we're going to do 2 of these holes with it. And then we're going to do the last one with WD-40, because that's how I did all the rest of them, and see if we notice any difference here. Man, that's rough whenever you lose track of which hole you're working. And yeah, I know you're supposed to back up and break your chip every so often. I was getting down to the bottom of where I left off. I will say, though, doing it by hand like this, that does seem like it's a little bit easier. Can't say if it's worth $15 a bottle, but hey, I got the bottle whenever I bought the mill. So, yeah, I didn't really pay any real money for it. Ain't bad. I can buy a gallon can of WD-40 for $25. What do you think I'm going to do, y'all? And the last one. Let's go back to the old standby here. Little devil do ya. Honestly, it may cut a little bit easier with Tap Magic over WD-40, but come on, man. You're splitting hairs at that point. Besides, I'll let you in a little secret. If you want to make your own Tap Magic at home, go buy WD-40. Go buy a can of acetone. Mix acetone 25% of your WD-40. So, for example, for every 4 ounces of WD-40, put in 1 ounce of acetone. Shake well. Put in squeezy bottle. There you go. You got your own Tap Magic. Well, cool. That's pretty. We just got to clean some chips out. But one thing that we do need to do here, I know you ain't going to be able to see it on the camera, so I'm going to use this slightly grody O-ring pick here for a visual aid. Everywhere around this, hang on, I got to figure out my life here. Yeah, there we go. Everywhere around this thing where we drilled and tapped a hole, look real close there. Focus. 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 There. See that big gnarly burr that's on that thing? That thing's big. Like big. I'm talking like elephant turd in a parking lot big. We got to knock that down to where we don't have any high spots, because keep in mind, this whole area here, this is a register surface where the back of that lathe chuck has to rest, and it has to rest flat and square. Pikachu, I choose you. Okay, that's our existing hole that we used as a pilot, because I've already got a chamfer in it. So I got to do the other 3. I want to try to keep these as consistent as possible, and I don't want to double dip on one of them, because whenever you hit the same hole twice, sometimes that can introduce a little bit of irregularity into whatever it is you're making. And what the hell, just for old time's sake. Give it a little quickie hit and run on the backside just to make it match up. Now, all these holes on the backside of this adapter plate for this back plate, they all got burrs in them and stuff like that. I ain't going to worry about that right now, because that's purely a cosmetic thing. But what I am going to do is, next time I have this thing on the lathe, I'm going to sneak back in here with a grooving tool or a real high angle cutoff, or like a diamond tip DCMT bit, and we're going to knock all that stuff down to where we can put a nice gentle little radius on here. That way we don't have any sharp edges that like to reach out and snag you. Okay, obligatory safety message follows here, okay? Whenever you're using compressed air for blowing chips out, drill cuttings, tap cuttings, whatever, make sure you wear your safety glasses or safety squints, allegedly, because, man, those things go everywhere and they exit at a high rate of speed. And if you get them in your peepers, trust me, it hurts. Slight pause for some house cleaning here, guys. Oh, no! So anyway, that's how you drill a hole and make sure you get it to land where you want it to go. Anyway, kind of coming full circle on this, back to the reason why we're doing all this stuff. Got our 4-jaw chuck over here on the bench, and I'm going to show you guys why we did what we did with this backing plate and why we needed to go from a 3-jaw to a 4-jaw and a 3-bolt pattern to a 4-bolt pattern. Here's our backing plate that we modified with our bolt pattern for both 3-bolt and 4-bolt mounting flanges. Here's our 4-jaw chuck. Now here's the reason why we did it this way. I took this chuck that normally bolts in from the backside, and I drilled it all the way through, and then I counterbored the holes to where the bolts can come in from the front side. That way I can leave this here, and also that way I can attach it, because if you look there, I ain't got room for a bolt there on the backside of that thing. At least not without having to carve a whole lot on this original backplate adapter for the spindle nose. I really didn't want to do that. Now this is where the plan had to deviate just a little bit. How I had planned on bolting this thing up was just drilling through from the face of this, because all of this area is solid cast iron. There's nothing here to damage or no risk at drilling through here. And I'd planned on just counterboring the holes to where I could drop a bolt in there like that. Nice, neat, and simple, right? Not entirely. This is a counterbore. And if you notice, it's got a pilot nose here, and what that does is this pilots off of an existing hole that you've already drilled, and then it's basically, it acts as a seeing eye dog for a pretty aggressive cut 3-flute end mill, but it makes a square bottom hole. That way we've got something square that our bolts can butt up to and attach and torque down repeatedly. Now where I had a problem with this is Buddy Bezos failed me. These were supposed to have been here yesterday, and they were delayed for whatever reason, and me being the impatient bumpkin that I am, had to come up with a workaround for it. Now, these counterbores, they're not a expensive investment, but then again, they're not cheap if you're just doing a couple of holes. So here's a way around that. What I did is I drilled my hole in the chuck here, all the way through for my 8mm shank bolt. And you can see right now that looks like a hot dog down the hallway. I took a 1/2-inch drill bit, and then I drilled down to the depth that I needed the bottom of my counterbore. And most people would think, okay, cool, what's so big, what's so great and cool about that? Well, here, I'll show you. The problem with using a drill bit to countersink a hole like that, especially if it's something where you're wanting to torque it down and keep it square and keep it consistent, is that. It's got a taper to it. It's not flat and square. So what I did is I took my bolt holes rather, and I drilled them to 1/2-inch, but I left it a little bit shy. I drilled these, I wanted my total depth on this to be 1.050 inches deep. That's 1 inch plus 50 thousandths. Well, I measured out the length of the taper on this drill bit, and this is just a little bit over 1/10 of an inch by itself. So I drilled my holes 900 thousandths deep. That's 0.900 or 9/10 of an inch for people that are on the simple system like me. Drilled them to that depth, and then I came in behind it and followed it up with this guy. That's a 1/2-inch 4-flute carbide end mill. Now granted, you've got to run it at very low speed, but considering we're going into cast iron here, it's a fairly soft metal, so it cuts pretty easily. But I zeroed my measurement off of the face of the chuck because I knew I wanted to be 1 inch and 50 thousandths deep at the bottom of my hole. That way I would have enough protrusion for my threads to have full engagement with my back plate here. I drilled this at 0.900, and then I chucked that up and I ran that down there at very low speed to flatten out the bottom of the hole and cut the taper out of it. So having to go through all of that, having to juggle all of that and jump through those hoops, that's what makes this guy so attractive, because it's a one-shot, one-kill deal. You take a hole that's 8 millimeters around, which is what this pilot nose pilots in, and then you just plunge it down to whatever depth you need, because that is going to cut a straight and square bottom hole every time. And had I had them here, it would have made this a whole lot quicker process. The heads on most metric hardware, especially when you're talking Allen heads like this, they're made to a specific dimension. Now, the dimension on the head of an M8 bolt on a socket head screw like this, it's a little bit over a half of an inch. I had a 1/2 inch end mill I was working with, so even though I got my hole bored out and I got it squared off at the bottom, these still wouldn't drop in all the way. So they ended up taking a trip for the last hoorah, if you will, in the lathe with the old chuck. That way I could skim about 20 thousandths of an inch off of the outside of the shoulder of them. And that way they'd drop in and, have clearance. That way they can go in and account for small irregularities and be able to self-align. So we're going to set this aside for a minute, and we're going to bring in the new kid. New kid. And I'll admit I spent a little bit of extra money because I got some features on this chuck that my old chuck didn't have, and I really liked. I liked the idea of having it. And that's part of the reason why we went through all the pain and agony of drilling the 4-jaw chuck to where it bolts through from the front, because this chuck is set up the same way. Another thing this style of chuck has going for it is these are a 2-piece jaw chuck. If you look close, you'll notice the jaws are 2 pieces, and they bolt down with an index dovetail here to where you can flip them around, or you can take them off entirely if you're working on something that's very small and very close tolerance, because the interior part of this still has the same bevel cut right here where the holding edge is to grab a part. And also, since these are all indexed to one another, if you got something large you got to grab from the outside, you simply unbolt the jaws and flip them around, and it grabs from the outside, all without disturbing the setup that you have on the main body of the chuck to your backing plate and to your spindle. That way you can make sure you maintain concentricity. Concentricity. I always had trouble with that word. Don't ask me why. Can't tell you. Words are hard, y'all. Now, these bolts don't have to be just crazy tight, but they need to be equally tight. So I'm trying to pay attention to putting the same amount of force on all of them. Not going to break out the torque wrench for doing this because, number one, there's probably not a torque spec that exists for these. Number two, honestly, I just don't feel it's warranted right now, but calibrated elbow ain't failed me yet. So let's mount this thing up and spin it and see what happens. Let's see how crooked we got it. Okay, now that the non-California quiet air compressor is kicked off where I don't have to talk over it, hashtag still nowhere near as fucking bad. Anyway, unfortunately, this is the downside of what you run into with cheap import machine tools from time to time. Sometimes you got to do a little fit and finish work on your own just to make sure that everything is as it's supposed to be. Now, I'm going to completely strip this chuck down, which honestly is something that I probably should have done straight out of the box, but it felt pretty good, so I figured, what the hell, let's roll with it. That, and I had a new toy, and I wanted to play with it. But I'm going to break this thing down. I'm not going to bore you guys with that on camera because it's going to be rather boring, dull, and, may qualify me for the monthly poster child of the Dull Men's Club. But anyway, we'll get back with you and let you know what we find in this thing. Get it put back together. That way we can get it spinning in a straight line and not in figure eights. Okay, I told you guys that I wasn't going to bother recording me digging into this chuck and see what was going on and everything, but that was before I opened it up and I found what I found. And honestly, right now, I'm just kind of pissed off about the whole deal. Let me show you why. So I opened this thing up, and the first thing that I found is this thing was just freaking packed, and I mean packed full of this yellow booger snot Chinese farm grease. And not only that, it was full of all kinds of, grinding dust, machining swarf from whenever they made this thing. Now, granted, this isn't a bison chuck, all right? But then again, it wasn't $600 neither. But it was $125, and I would expect better for $125 because here's what I found in this thing. Starting out with the backside of things, the back plate on this thing, I mean, it's got sharp edges and burrs everywhere. But take a look at this surface, man. Here where it backs up the pinion gears inside the housing. Look at that. I mean, that's just, yeah, that looks like that was carved with a stone axe, man. There's sharp edges on this thing everywhere. And I mean, I'm talking like sharp, big time burrs and stuff. The scroll gear, and this is what closes all three of the jaws up. You've got three pinion gears that lay in with this. This scroll gear, the face of the gear itself isn't that bad, but all around the perimeter of this thing, it's a burr fest, man. I mean, you can actually see them in the reflections of this thing if you catch the light on it just right. This thing is some kind of rough. And just for the final thumb in the eye on that, these pinion gears that close up on the scroll, if you look, you can see the wear pattern where they've been making contact. It's all over the chart. These things are actually kind of halfway bent just a little bit from the looks of them. Not to mention they kind of went overboard and got a little ape shit crazy with their gear cutter whenever they were cutting the gear teeth into them, and they actually cut back into the support surface where this is pivoting into the main part of the chuck housing. So what that means is I get to spend a couple hours going around this thing with some needle files and some stones to knock down the rough edges to where I can actually get it moving free like it should. That way everything can close up the same. Hopefully we can knock that damn run out of it, because if we can't, after going through all this crap, oh yeah, it's going back to Buddy Bezos with a very long and detailed list of deficiencies that I've found in it, and they're probably not going to give a damn, but at least I'll have it off my chest and it'll be out there. I'll let you know. Fast forward several hours in the future. Insert SpongeBob voice here.
An indeterminate amount of time later.
Anyway, why are you looking at me like that? What? Why are you laughing? I can't do a damn thing serious around her. She starts laughing. I don't know why. Adulting's hard, y'all. So anyway, at the end of it all, I got about, call it 3 hours in fixing their fuck up on this Amazon special lathe chuck that I thought was going to be a good buy when I first bought into it. I don't put a whole lot of stock in reviews on like Amazon, Harbor Freight, whatever, because the thing is, human nature, if something works and it's okay, people pretty much leave it alone. Usually, most of the time, if you see a review on a product, it's either something where they were offered the product for free or a lower cost, and it kind of nudged them in one direction. Or number two, it was an absolute flaming pile of dog shit, which this was not, but it was flirting with that. But those people, they get butt hurt, and then they've got to tell the world about how horrible their experience was. Now, was my experience horrible? No. Was it up to my standards? No, but then again, I kind of knew what I was getting into because y'all know me. I'm a cheap ass, okay? I shop at a price point. That being said, this one, there was a couple of glaring failures where they really could have done a better job. If you guys will remember, all the burrs and the sharp edges that I pointed out to you guys a little bit ago in this video, that's crap ass finish work. I mean, it would have taken them 5 minutes when they were building this thing after they cut all the parts out and they married everything up and they got it all ground in. It would have taken 5 minutes to deal with that, and it would have totally changed my opinion of this chuck. Now, am I going to throw it out or send it back to Amazon and get my money back? No, of course not. Not at this point. I've got the time invested in it to where I fixed all the problems it's got. And why would I give that away? I'm not. I'm not happy about it, but hey, you get what you pay for. So let me show you guys what we wound up with on this thing. We had 7 thousandths of an inch of run out before I deburred and knocked all the rough edges off all the guts in the chuck and everything. Got it back together. Here's where we are now. Pay attention to the needle right here. Now it is moving, but it ain't much. And the thing is, in this case, that's what we want. We got right at about 1,000th of an inch worth of run out, 3.5 inches away from the jaws of the chuck. Considering it's cheap Amazon machine tools, I will take that all day long. So at the end of the day, we got a tool we can use, even though we had to put a little bit of sweat equity into it to where we could make it useful. You know, that's kind of the trade-off with stuff like this, especially whenever you're trying to shop on a budget. Could I have got a chuck that was out of the box, damn near perfect with no run out? Maybe, because that's not always a guarantee. A lot of it has to do with the state that, my lathe is in, and that's a variable that nobody has any control over because every single one of them are different. It doesn't matter whether it's new, old, beat up, well cared for. It's going to come down to what you've got it bolted to. Stuff like this, sometimes you have a gotcha that jumps up out of the woodwork and catches you by surprise. This was definitely one of those cases. We got a piece that now we can depend on, and it's going to go back to where we expect it to go back to every time we use it. Not only that, we don't have to sit there and wonder, I wonder if it's going to come out round this time. We know it will because we put the time into it to make sure that it does what it's supposed to do. This is kind of drug on a little bit, and I apologize for that. Let's go down the checklist here. Let's see here. Talk about gearhead stuff, talk about tool stuff. Oh, yeah. Let everybody know that my wife unit is doing an amazing job with what she's doing to help out with the channel here. I appreciate that very much greatly. Like, bigly big. Big. But also, oh, yeah. Shirt change. Got it. I'm sorry, y'all. I forgot last time. But, hey, it may be a little bit immature, but what can I say? I like it. But on the upside, I've got all the stuff and all the pieces and parts in place now to where I can make the stuff that I need to move forward on Liberty Risk. That way, we can pick back up with the Ramblin' Park stuff on Thursday night. That way we can, start making some headway on the boys' bike. I honestly, at this point, I'm kind of ready to be done with that thing because I've got something else. Well, I got something else on deck. I ain't going to tell y'all what it is, but I will give you a little hint. It's a Kawasaki. What else? Oh, yeah. When this thing was new on the showroom floor, you were probably still watching Miami Vice on ABC at 7 o'clock on a Friday night. I'll show you here in a few weeks whenever we get Liberty Risk off the lift and we got a vacancy here in the temple. That way we can start into a new direction. Slight sidebar number 2 here, guys. I wanted to give a big shout out to Angel, Red Rider. She swung by the Ride Factory the other day, and I gave her the nickel tour of the place and just kind of showed her what we're about and what we do there. And she got to meet the emotional support fuzzballs and, see some really cool stuff that we got going on up there as well. So you guys take a few minutes, head over to Red Rider's channel over here on the YouTubes. I'll have a link to her channel down here in the comment or in the description section rather. Why do I always say comments? I don't know. I mean, maybe it's wiring. Yeah, we're going to blame it on that. But anyway, she's good people, and she's got a hell of a way with old vintage Harley stuff. She's got a real cool shovel that she works on, but also we're bringing her around to the better side of things. She's got an old Yamaha that she managed to scab up, and she's been making some headway on getting that thing put back together. That way she can see what life without valves is all about. Go check her videos out on her channel. You'll figure it out. Anyway, I was glad to have her as a guest at the Ride Factory. Glad to show her around. Now, for you guys that may be new to my channel here, or if it's been a while since you've seen me, I apologize. It's been a little bit. I've had to, I've had to do adult stuff, like in the real world, job, house, dealing with hurricane crap, whatever. Semi-shameless plug here, and I'll fully admit this, but if you guys like what we're doing here on YouTube, if you like what we're doing here in the temple with Tool Talk videos, also with Ramblin' Parked, all the bike tips, bike tech, things like that, poor boy tricks on how to save you some money and not go broke while you're getting the job done, come over and check us out over on the Patreon side, okay? We're building one hell of a good brain trust over there, and we're adding people every single day. And the more knowledge that we have condensed down in one small spot, the deeper that pool gets. And I know whenever I make a post over there, if I have questions or something like that, I've always got those guys over there ready to jump in to help me out if there's something that I don't know. Because believe me, that's a lot, okay? I'm just some dummy that happens to stand in front of a camera and makes inappropriate off-key comments at times, and people find it funny. But I will say this. The knowledge base that we've got going on over at Patreon, it's huge. It's big. And there's discussions that we can have over there that we can't have here. And yeah, we'll leave that at that. However, it does not cost you one plug nickel to join as a member of my Patreon. We have free membership options. I want you guys to know right now, I don't hide anything behind a paywall. I don't, it's not a pay-to-play thing. If somebody's got a question, hey, put it out there. Hit me up. I'll get back with you and I'll help you out as best I can, all right? If I don't know the answer or if I can't fix your problem, I'm sure I got some people over there in my corner on the Patreon there that will definitely chime in, and one way or the other, we'll get you right and get you square. All right, guys, that's about going to do it for this week's Tool Talk at the Temple, okay? Now, I want to remind you guys, just to put it out there, okay? Hit the like button. If you haven't already, hit the subscribe button. The main thing is, hit the share button, because the more that we get the word out that, hey, old bikes don't have to be expensive. Hey, old bikes don't have to be broke all the time. The more we get that out there, the more people we're going to have going out into the garage and saying, you know what? Let's go do the damn thing. I got a cup of coffee over here with my name on it. I got a motorcycle I got to make parts for. So I love y'all. I'll catch you on the next trip, okay?
Force will be with you, always.